I think we are live. Hello, everyone. Let's wait and give it a minute so that few more people can trickle in. If you can hear me, guys, drop a hello in the chat and tell us where you're joining us. Okay, I think we can start. Hello, everyone, and welcome to day one of TestMu conference. I hope the energy is high because we have a packed day. A lot of interesting sessions lined up for you guys. So grab your coffee and get comfortable. I am Kavita Doshi, Senior Marketing Specialist at TestMu AI, and I'll be your host for this session on Flaky, Fragile, and Forgotten, the fall of a test automation project. And I'm really glad to have you all here. Two quick things before we jump in. If someone in this session clicks for you, post it on LinkedIn or X, tag us and use hashtag TestMuCon. That's how the rest of the community find these conversations. Number two, questions go on in the Q&A box, not the chat. Drop me in and we'll take them towards the end of the session. Okay, so most of us have that one repo, the test suite everybody's little scared of. Tests that fail for no reason, get rerun till they pass, and eventually just get ignored. A speaker inherited one of those. And this session isn't a best list practice, it's a postmortem. How does a test automation project actually fall apart, and what would you do differently so yours doesn't? Our speaker today is Mesut Durukal. Mesut is a QA capability leader at OMP, where he works as a cross squad quality leader focused on scaling capabilities across teams and improving the efficiency and impact of QA practice. He has spent his career on test automation, CI/CD transformation, and building quality into the development lifecycle. Please join me in welcoming Mesut Durukal. Mesut, over to you.
Thank you so much, Kavita. I hope my presentation is also on the stage so that we can start. All right, yes. So thanks again for the nice introduction, and hello everybody from wherever you are joining. Greetings to all the places you are from, because I know there's a big audience joining from a lot of places on earth, and TestMu conference is such a community collecting a lot of people with different backgrounds from different locations and discussing the same principles and same mentality, which is improving the quality, right? The quality in the products and in the processes that we are following. And this is one of the things, like we have test automation projects in most of places. And of course, flakiness and the stability or the robustness is one of the main things that we try to maintain. And in the session, we will talk about this. But basically, again, for about myself, I'm based in Belgium. This is where I just relocated this year. Previously, I was living in Japan. I lived there for about 5 years, and I'm originally from Turkey. And I'm still trying to get used to 18 degrees in the middle of August in Belgium. It's a very nice place, but I cannot say the best for the weather, but this is what it is. So, in the session, actually, this is a real life story, right? In our project, I really have some flaky tests. I have some fragile tests. And actually, what happened a few months ago was after a library update, notes, some package updates, all the tests, almost all the tests start failing because the locators were somehow related to some chain items, and that from root was updated, and everything related was started failing. It means our test was really fragile. Like even if some DOM structure or the layout of the page changes, they could still run, but they didn't. So it means it really depends on the page structure or some relying on some DOM elements, which is really fragile, which may cause test failing with a small change. And I have some forgotten tests as well. Like we have some tests failing for a long time, and everybody lost their faith and trust on this test. Nobody wants to fix it anymore because we know that it is very flaky and fragile, and even if we try to fix it, maybe it will run for a few days and then again will start failing. So this was the real life issue. Let me know if you have similar problems, issues in your project, so that we can make this session a little bit interactive and we can go over these things at the end if we have time. But I believe Flakiness is in most of the test automation projects, right? It is a very common test smells and a very common code quality issue. But what happens when we have flakiness or fragile tests or some forgotten tests in the repository? First of all, it means post, right? Normally, the pipeline might pass directly and it might be green, but it is not. It is failing. And the root cause of the failure is not a bug in the product, but an issue in the test automation code. Maybe just an asynchronous wait or not code which is not properly implemented, something related to the test code quality. So which means we have to stop the pipeline and check the root cause analysis to try to understand if it is a real bug or just a false alarm, which means just a test automation issue. And it means it is maintenance, like we have to fix it after understanding the root cause. So all these things are already a waste of time. It slows down the new development activities, the new merges coming into the main branch, and also spending time and effort or resources on this root cause analysis. And in time, of course, it will increase our technical debt. If we have a lot of failing tests, then we will not have time to immediately fix them. And of course, the backlog will grow and grow, and the number of failing tests will increase in time. But on the other hand, I believe which is even more important is people will start losing their trust in the tests because they know that tests are already failing even without the product bugs, and it is not reliable. This is what reliability means, right? If the test is reliable, when you run them, you should be relying on the results. If it is saying a pass, then it means a pass, which means even there is no silent horror cases. Like that is also an issue. Like false alarms is one thing. When there is no bug, your test might be failing, which is a false alarm. But on the other hand, when there is a bug, your test should be finding it. Otherwise, it means it is a silent horror case, which will appear in the later stages. Normally, our aim is to try to find the bugs as early as possible in the early stages. But if that is not the case, what will happen? We will have some escaped bugs, right, which are found in the production environment, which would be facing the customers and users, which will be a prestige issue for our product and the company. So that trust issue is, I believe, even at least as important as the cost maintenance and the technical debt issues. So I will go over a lot of issues, root causes stemming in these kind of reliability issues. I think I have 10 different categories and we will analyze them one by one. So let's start with the first one, which is number one is tests taking too much time. In our pipeline, I think we had 4 consecutive stages for high priority tests, medium, low, and some other tests. Each were taking for about 1 hour. So in total, the whole set of tests were taking for about 4 hours, which is too much, right? Like we cannot wait for 4 hours for every single commit or every single merge request. That is too much. And when I tried to understand why it was failing, I mean, I did not have to look too much into that because it was very obvious. The reason was we have too many test cases. I mean, what is the problem about having too many test cases? When I tell this to some people in my team, they were surprised. Like they were saying, it is the first time we are complaining about the number of tests from a test lead. I said, yes. I mean, okay, of course, it is good to include a lot of test cases, but we should check the value that they are adding. This is why I put this image. Like sometimes quantity is not always equal to the quality. Right? You can add a lot of test cases, but are they really finding bugs or are they really covering the correct scope? Because eventually, when I checked the test cases added in the system level, I realized most of them were not even supposed to be in the system level. They could be done in component level or unit level. So tests were done at the wrong level. Think about the test pyramid. We should have the unit test covering the most scope, and then integration, and then system level, and finally the acceptance test. So I saw some test cases, end-to-end feature tests, UI tests, which are trying to just verify that some elements are on the page. I mean, do this with some component tests, right? Why are you trying to see that some elements are on the page? Because probably end users are needing this. Then why do they need this? It should be in the end user flow. Just cover the flow, end user flow itself. Like if you are trying to see that the button is there, then do not just check the button is there, but click it and observe the action results and how it reflects in the page. So this is something that I added in my rule set. Eventually, at the end of the presentation, I will share a code review guideline, which I try to make sure that everything is satisfied. But this was one thing. Like in your end-to-end system test, system level test, UI tests, try to cover some user transaction. I don't want to do some static checks. That can be also already done in the component level. So root cause analysis 1. Respect the test pyramid and try to cover everything at the correct level. Do not try to cover everything in the system level. Then you will have too much load and unnecessary test execution time, test flakiness. Because if you have 500 tests, it's not only time, but also increased risk of failure, right? You are trying to run a lot of tests. Maybe some of them would be conflicting with each other. Actually, this is another reason I will tell in the later slides. But when you have too many tests, you should also think about the design and the execution order and the most efficient pattern of executing them. But let's go to the next root cause analysis and try to understand what some other reasons we have for these reliability issues. Again, tests were taking too much time because I realized we didn't really make use of some shortcuts and wirings. A very simple example. Like to execute a test, for every single test, we have to log into the system. You know what we were doing? Every single test we were logging into the system. We don't have to repeat this, right? Log into the system once and get the session credentials or all the session information and reuse it. Just start from there. You can just read the page details, and on top of that, you can continue with the next steps. So this was a step which helped already a lot in reducing the test execution time. Or this is a very simple example, but I'm sure you can find a lot of similar examples. Like, let me give you another example. In our system, there's a drop-down menu in which you can change the mode of the system. There are two modes, live mode and draft mode, and you can click to the drop-down menu and you can select the option to switch the mode. But you can do the same by just navigating from the URL, like just add a extension in your URL, like /draft, then it will already change. It will do the same what the drop-down menu item is doing. So no need to do each time over UI, right? I understand UI feature itself should be verified as well, but you don't have to do it in all the tests. Verify it once, and in all the other tests, just use the URL, because drop-down menu is already, we know that it might be flaky or fragile or just slowing down the flow, just instead of navigating to another URL. So please consider these kind of inefficiencies and try to utilize a lot of shortcuts or avoiding repeating the same steps in a lot of spec files or in a lot of test cases. Let's move on. One other root cause I actually just mentioned was the repeated steps. Like sometimes I realize that we have a spec file in which there are multiple test cases. And when I read the tests, I realize that, okay, we are doing some steps like log in, go to some specific page and do some arrangements to do our verifications, and then eventually verify something. And then in the next test, you repeat all those preparations and then do another verification. So what can we do is obvious, right? If we do all these kind of preparation steps and then do this and do all verifications at once, no need to split those cases into different tests. Just merge them and avoid repeating the same steps again and again. But this is a little bit human engineering. Like sometimes my team members are asking, okay, tell me where I have to stop, because we should find a sweet balance, right? Sometimes if you try to merge everything in a single test, then it will be a huge test case. It's also not good. But where to stop, what to merge, what to split, this is a little bit human engineering. You have to find the sweet spot where you don't repeat anything and where test is still maintainable, still manageable, and it is not too long, it is not trying to cover more than expected. So these kind of things are the real design, because otherwise we can just ask AI. By the way, I will share some AI skills at the end, which we already use. But still, this is why we still have some human engineers in our teams, right? Otherwise, just ask AI to implement all the tests. But at some point, as a human, you use your natural intelligence instead of the artificial intelligence. We use our natural intelligence, and we have the feeling of a human. So we can judge if this test is covering what the end user is expecting, or if there are some other steps that we need to cover, or if there are some improvements who can improve the user experience, UI, UX. Those kind of things are really difficult to cover by AI, right? This is why AI cannot still replace 100% the manual effort, but we are still there in the teams to ensure the quality. Let's move on. As I said, there are still more root causes. I listed 10 different items. Number 4, still about test execution time. One other reason tests were executing too much time was just the infrastructure we were using. Like our setup was, we used Selenium, and then we had the WebDriver IO framework, orchestrating those Selenium tests, and calling BrowserStack to raise some browsers and run our test against those browsers. But what's the problem about this setup? I'm not saying this setup is completely wrong, but we didn't need this. Because, in BrowserStack, you can even raise some native mobile devices, and you can test your applications, mobile apps. But we didn't test mobile apps. So normally we didn't need BrowserStack. So there is an extra layer in this communication chain, right? If we don't use this, if we eliminate this, it's already helped us to reduce the execution time. Instead, later we changed our framework and the setup. So instead of Selenium plus WebDriver plus BrowserStack, we just start using Playwright. So it can already use those different browsers, right? But nowadays we don't even run all our tests against all the browsers, because these days modern browsers are supposed to support most of the features. Like the whole set you can run against only maybe one of browsers, and maybe only the smoke set or the high priority test, even not after every commit, maybe nightly or once a week, whatever. You can try other browsers, but you should think about if it is necessary to run every single test execution against all browsers, or the infrastructure or the tool setup you are using is the best serving to your needs. Again, I'm not saying Cypress is the best, Playwright is the best, Selenium is the best. Any one of them might be the best for you, but you should analyze your requirements and try to figure out what setup is the best for you. Otherwise, if you realize some improvements and any change can help you with the test execution time or Flakiness, robustness, then you can make an initiative to change your setup. Moving on. This time, not only about test execution, but about the readability of the tests. Again, real-life examples. Sometimes I saw some tests having only one line, like calling a function, verify something. What's the problem here? I mean, just by reading one line, I don't understand anything, right? I have to go into the function to understand what I'm verifying. And when I go into that function, then I realize that function is calling some other function. So there are too many abstractions. It shouldn't be too difficult to understand what we are doing, right? Test intention should be very clear. This is one thing I really highlight to my team members. Like, of course, reusability, avoiding duplication is very important. But when it comes to tests, readability, understandability, maintainability, these kind of things wins over reusability. I mean, sometimes you can even repeat the same assertions in different tests, because that is the intention of test, right? Assertion is the main thing that we are doing in the tests. So it should be explicitly written. I really dislike these kind of verification methods, collecting each other, collecting some different functionalities. And also it avoids single responsibility principle, right? One function should be doing one functionality. Otherwise, it is difficult to maintain, it is difficult to understand, it is difficult to read. So it is just a weak code quality, I would say. I will show some more examples, but over-abstraction was one thing which makes it really difficult to understand. And even if the test fails, you try to understand where it fails, right? Because normally it shows at line 15 it fails, but when you go to line 15, you just see a function call. Okay, from line 15, then you go to line 25, then from line 25, you go to another line. It is really very difficult to maintain and do the troubleshooting. Again, I'm not saying do not use any reusable function. Of course, we need them. But again, try to find the sweet spot where you balance this readability, maintainability, and the reusability. Again, a human engineering judgment, which cannot be very easily done by AI. A related root cause analysis, not only the over abstraction, but also hiding the logic of the test. Again, it's a similar show, like wrapping around different verification steps into some functions which are placed in some other files. Like I go to spec file and I read, and then I need to understand one function or just a helper method, and it is linked to some other place in another file, maybe a page file or a helper file, and I need to go to there. And then again, I have to understand what is happening inside. And if there are any other calls, I have to investigate them as well. So test intention, just after reading the test itself, should be clear, right? Starting even from the name of the test. Naming is, you might see this very simple and obvious, but believe me, even the naming sometimes would impact a lot about the readability or understandability of the tests. Because sometimes you read the test title or the name, and what the test is doing is completely different. Or sometimes you read and you don't understand anything, but on the other hand, sometimes when you read the test, you immediately understand what you are supposed to see. Yes, it looks simple, but naming convention is very important indeed. Let's move on. Next root cause analysis was again related to the same symptom, which was the poor readability, but this time not only over abstraction, but also some conditional verifications. These kind of functions, trying to cover as much scenario as possible, are called as God functions in the terminology, right? Trying to do too much, trying to cover all the conditions, accepting a lot of parameters, and depending on the parameters, it is going to different states. I mean, again, you are trying to cover a lot of things, but think about where you call this function. You pass some parameters and you try to understand the values given to those parameters. And inside, you try to understand which parameter value is going to which state. It is again difficult to understand. And it is, again, in a failure case, not easy to fix, right? Think about if those functions are split already in the first place, then you know where to fix. But if everything is one place, then it is really difficult to find where exactly it is failing. And also fixing the one big function, depending on the failure reason, is also not as straightforward as having small single responsibility principal functions. Let's move on. Next root cause was having the Flaky test in the first place. Like sometimes we merge some test cases in our repository and it starts failing on the same night. And when I investigate why, because I realized we did not make sure that the test was stable in the first place. When I talked to people, they were saying, okay, I tried executing this test and it was passing. I mean, it is always like that, right? It always passes in your machine, but when you push into the pipeline, it starts failing. That's always the case. So we should try on the pipeline on our branch before merging to see if it is stable on the pipeline. Because why it is running on your machine but not on the pipeline? Because it might even be related to the timing issues, even the execution speed, or the time for the page loading or the loading of the components on the page. And also might be related to some suite dependency issues. When you run the test itself on your machine, okay, it works fine. But when you run it in a suite together with some other tests, there might be some conflicting issues, right? For example, I'll give you an example. In our sum of tests, it is trying to reset all the filters to see the whole list of the products, for example. And another test is trying to set some filters to see that only related products are shown. So when you run this test parallel, one of them is trying to set the filter and the other is trying to reset all of them. So you see there will already be a conflict issue, right? So what we do, we either design our execution patterns, which test will be depending on what other, or maybe we can already merge those test cases. So first do the filtering and then do the reset so that they don't run parallel and they don't conflict with each other. But in short, running tests in your local environments is not always okay. And we have to see that it is stable when running in the whole suite, and not only one time, run a few times to see that it is stable. Because some issues are not happening immediately, but under some conditions, you see that they are failing, right? So I advise my people to run a few times before merging to the main repository. And one other thing was in that regard was they were saying, but okay, I understand we should do that, but today my team is expecting me to merge this. But we didn't complete all the quality checks. But they really want to merge as soon as possible. So I'm asking, what do you want me to do? Should I skip the code review or should I skip some quality checks? So the lessons learned for us should be start as early as possible. This is agile testing, right? Whenever the development team starts, you can already start preparing for your tests, and do not try to complete all the QA work in the last 2 days of the sprint. Then we will have these issues. Moving on. Next symptom was silent horror cases, where we did not find the problems which are existing in the product or in the code. One root cause for this symptom was using a lot of try-catch in the test. I mean, try-catch can be used under some conditions, but only if you have a valid reason. Otherwise, your query didn't work and you silently return, it means something might already have happened there and you don't complain about it. You just catch the error and you don't fail the test, you just continue to the next steps. Which means test is not complaining about this failure and just trying to cover these fail cases. So again, I'm not saying 100% avoid using try-catch, but please be careful about what you are doing there. And if you are silently returning or you are properly covering the fail cases. One other symptom was the poor maintainability. Again, when we have something to fix, we had to fix it in a lot of places, because the reason was it was duplicated in multiple places. So it is better to follow a standard approach, like if you are using page object model or any other implementation pattern, please try to apply it properly. Like, for example, if you have methods, then instead of spreading them around spec files or maybe even including in the component files, try to collect them in some page files or helper functions, for example, so that you know where to find it. If you need it again later in your spec files, then you know where to refer. Or put all the locator selectors in some component classes so that you know where to find them. So it's not only developing a standard, but also helping you to avoid duplication. Moving on, I think this was the last root cause analysis. On this, this is a screenshot from our pipeline. Do you see that a test is failing? I guess you cannot. We could not either. I mean, because we didn't have visibility, like we didn't have a proper reporting. People were trying to go to pipeline logs and trying to search for fail or failure, whatever keyword it is, just trying to find them in the whole logs. It's not convenient, right? But nowadays we developed a report which clearly makes a statement like what test passed, what failed, what was flaky, what was retried. So you can immediately see the results of individual test cases. There are built-in reporters in Playwright and in other tools. And also there are some other tools, open source tools you can use. But whatever you are using, please try to make it very evident, very visible, and traceable. Like, do not lose the test history. Keep all of them with all the artifacts, right? Screenshots, traces, logs, everything you need, so that even if you need to refer it in the future, you still have it. Because sometimes I see the report is there, but it is immediately deleted after the ephemeral environment is gone. Please try to store your test history, at least for some time, so that if some tests start failing again, you can refer to the previous artifacts. All right, so this is a summary. Please try to implement, define, and automate your test cases in the correct level. Please do not try to do component checks in the system level tests. Respect test parameter. Choose the correct tools and infra. If you don't need to make all browsers up and running, then don't do it, right? It is just a waste of time and waste of resources. A lot of jobs will be waiting in the pipeline. Design your test cases efficiently. Please try to avoid repeating the same steps. Avoid automation and type patterns like code quality related issues, over-abstraction, even naming conventions, and putting correct scope in the correct files. Just avoid some anti-patterns. Eliminate duplication if you have functions like doing the user interactions on the pages. Repeat it in multiple places. Try to reduce or eliminate this duplication. And ensure reliability in the first place. Run your branch before merging into main on the pipeline a few times to see that it is stable. And then you can merge after making sure that it is reliable and stable. And improve the reporting. This is the last thing we discussed. These were all the things which affected the flakiness and the fragile test in our repository. And of course, at the end, you did not think that I would finish my talk without mentioning some AI skills, right? Nowadays, in all talks, you can find some AI-related topics. So this is what we will talk about now. So after having all these observations and lessons learned, I developed some skills. First, even just for defining test cases, it's not even automation, right? Even just for step-by-step test descriptions, I made an AI skill, which is first connecting to our issue management tracking system, which might be Jira or Azure DevOps, whatever tool you are using. It is connecting to them with some MCP servers and reading all the feature details, like what is the acceptance criteria, what are the requirements. And after reading all these details, I have some skills and guidelines, and with some decision criteria. What should be a correct component level test? What can be a correct integration level test? What can be a good system test? Reading all these decision criteria, it is making tests in different levels, and I already prepared a template for the expected output, which is a markdown file. So after this, skill generates the test cases. You can see the output in a markdown file so that you can put in your repository and raise a pull request for asking review from different people. Because previously, before I developed this approach, everybody was doing the test reviews in different ways. There was no standard approach. Someone was just preparing a TXT file, simple TXT file. Someone else was preparing an Excel file, and the reviews were not trackable, right? It was offline. It was just on some Teams chat or maybe email. But now all the reviews are already in the repository. They put some comments and you can make the discussion and eventually you can close the comments. But even after merge, you can still, after a long time, you can still refer to the test file and see the history and the previous comments, right? All the review is already trackable with the help of AI. This is the AI assisted test definition skill. Next, after we have all these tests in different levels respecting the test parameter, then the next step in the test lifecycle is the automation, right? Or implementation. Again, for this, I made an implementation guideline, like what do I expect from a good code? This is the thing that I referred in the beginning of the presentation. Like components file should be, locators should be collected in the component files, and all the other patterns and good practices and anti-patterns I want to avoid. They are all the guideline, and the agent is reading that. And I already have the markdown, having all the test details, so that it is generating the code by respecting the page object model. And eventually I can see the spec file, page file, and the component files generated by AI. But still not finished. There is one last step, which is making the pull request or the code review readiness. Like eventually I make a rule set, and eventually after defining tests and implementing it, it is checking if all the rule set is followed. Like, did I avoid parameterized and conditional verification methods? Do I have any duplication? Am I adding any new implementation which was already in the repository? Because, in the big repositories especially, it is not easy to figure out if something you are adding in your branch, in your PR, was already in place or not. Sometimes it's not easy because the repository is already huge. You have a lot of files in different folders. So you cannot very quickly investigate all of them. But AI can do. This is the power of AI, right? This is the power of machines. For managing big data, this is the place where we can get the maximum efficiency of it. So this kind of checks, checks can be done very easily by AI. Does each function have a single responsibility or not? Or I'm adding just an abstraction layer, which is doing nothing but just calling another function, which is just a pass-through. There is no reason to do that, right? So all this kind of rule set is there, and we are making this to reduce again the rounds of code reviews, because previously I was putting a lot of reviews and the people were fixing them and doing a lot of requests, and I was doing a second round. But eventually, after start using the skills, we observed that it is way quicker, way faster, and way less waste of time. So final caution, of course, use AI, but please beware of some risks. Sometimes AI might be doing some hallucinations. Please do not blindly trust AI. Of course, use it, but always review it eventually. Because again, even if not only for hallucinations, but of course for some efficiency issues, for some human judgment, we need a final eye, right? And over-reliance, which makes you, after some point, being not knowledgeable about what's going on in the repository. If you do always wipe coding, after some point, at some point, we don't know what the code is doing, right? It is a little bit dangerous. So please always try to be in the loop and try to make sure that you know what the code is doing. There might be performance issues. AI is sometimes making code, but sometimes when you ask, okay, this is good, but can we do that in another way? I had this issue a lot of times. AI was responding, yeah, you are right. This is correct, but there is a more efficient way to do the same. So please, again, try to be careful about performance issues. And finally, make sure that every time you run the skills or you make a query, it means you are spending money, right? We, of course, we might have some resources. Our company is giving us the chance to use it, but it is in our hands to minimize the costs and be more efficient. So this, I believe we still have at least 5 minutes. So if there are any questions, I'll be happy to answer them. But if you have any specific questions, please try to reach out to me. Feel free to get connected. This is my LinkedIn profile. You can find here. Thank you so much.
Thank you so much, Ms. That was such an amazing session. An honest postmortem of how a suit decays is worth more than another slide about best practices. And I think a few people recognize their own repositories today. And thank you for sharing the amazing AI skills. I think everyone was waiting for that towards the end of the session.
Thank you.
I think we can go ahead and take a few questions. There are some interesting questions people have asked.
Sure.
Okay, so coming up with the first question, what's the first warning sign an automation project is dying? How much of flakiness is really a tooling problem versus a people problem?
I think the first sign would be, again, people losing trust in tests, because when I first joined my project, I immediately start some complaints about tests are taking too much time, they are failing too often. You will already understand that the tests are not reliable anymore. People cannot rely on the test results anymore. That would be one of the first signs. But of course, you can check the number of failing tests as well. This is why I was suggesting to keep the test history. Do not check only the latest run, but of course, with a historical record, you can understand the percentage of test failures and the passes. And the second part of the question is how much of flakiness is really a tooling problem versus a people problem. I want to understand people problem as human engineering. In that case, I would say it would be mostly the second part, human people, or the engineering problem. Because whatever tool you are using, like if you use Selenium, if you switch to Playwright or maybe Cypress, it doesn't mean that all your flakiness will be gone, right? It is not only about tooling, but it is mostly about the way you implement your test cases. I hope this answers your question, and we can go to the next one. Kavita, you are muted.
My bad, sorry.
Yeah.
So the second question is, what are the alternative strategies to eliminate problem of flakiness in CI/CD pipeline apart from running over multiple workers parallelly?
Running over multiple workers actually does not eliminate the problem, but what I was saying is run it multiple times before merging to see that if it is already stable and not flaky. But also not only that, but also following the good implementation practices, and in the meantime avoiding anti-patterns are the other things that we can try to do to maintain the reliability and robustness.
Perfect. Let's take up the last question, and then we can wrap up the session.
Yeah.
When facing intense delivery pressure, what strategies proved effective in securing organizational buy-in to pause and address technical debt in automation?
Yeah, this is the thing I'm having right now as well. Like this is what I was saying. Like people are trying to merge their tests as soon as possible, very quickly, because a team is expecting the stories to be closed, including the automation tasks. But I'm not finished. I still have some code quality checks. So what we can do is we should be prepared in advance and maybe share the automation tasks as well. If only certain people are trying to automate test cases, like if it's only the quality assurance members, then it will not work, because quality should be a shared responsibility. Sometimes the development should be jumping in to help in. Otherwise, this approach, what was suggested in the question, I think it will not be possible most of the time. Like we can pause and first try to reduce technical debt and then delivering new features. That will not work. This is, I tried a few times, but believe me, companies, product leaders, they don't want it. They won't stop, because acceleration is one of the key factors for the companies, organizations nowadays. They will not stop. But what you can do is try to reduce this technical debt in the meantime. Whenever you have bandwidth, try to do this on top of your tasks, so that for your tasks, it is better to share with other people. And sometimes I realize that even QA members do not want to share their tasks. They really own the test tasks, and they don't want developers to support. Please consider that quality is a shared responsibility. Anybody can jump in and support automation, so that the quality assurance members, quality engineers, can deal with those kind of technical debts by having these kind of additional bandwidths.
Perfect. Thank you so much, Mesut, for the amazing session and taking up all the questions. For the questions we could not pick up, all these questions will be answered on our community channels. So stay tuned. Thank you so much, everyone, for joining, and enjoy the rest of the conference. Thank you, everyone. Thank you, Mesut. Bye-bye.
Bye.